Let's understand few definitions before we explore the binomial coefficient, as they will help us in understanding the concept of binomial coefficient better. First is factorial. Factorial of a non-negative integer n is the product of all positive integers less than or equal to n. It is denoted by n's factorial and is calculated by multiplying all positive integers less than or equal to n. Let's see few examples to understand factorial better. Factorial of 0 is 1, factorial of 1 is 1, factorial of 2 is 2 times 1, which is 2, and factorial of 3 is 3 times 2 times 1, which is 6. Next one is sample with replacement. Sample with replacement means that we can choose the same element multiple times from the sample space. Let's say we have a jar with 3 balls of different colors, red, green, and blue. If we sample one ball at a time, it has to be returned to the jar before we sample again. This means for every sample, we will always have 3 possible outcomes. This is called sample with replacement. If we generalize this to n balls and k samples, then by the multiplication rule, which we saw in the previous video, we have an raised to power k possible outcomes. Now let's compare this with sample without replacement. Sample without replacement means that we cannot choose the same element multiple times. Using our example of jar with balls, if we sample one ball at a time, it will not be returned to the jar before we sample again. This means after every sample, we will have one less possible outcome. This is called sample without replacement. If we generalize this to n balls and k samples, then by the multiplication rule, we will have n times n minus 1 times up to n minus k plus 1 possible outcomes. Next, let's see what ordered samples are. Ordered samples are those samples where the order in which the elements are chosen matters. For example, let's say we are taking 2 balls from the jar. If we choose red ball first and then green ball, it is a different outcome from choosing green ball first and then red ball. This means the order in which the balls are chosen matters, and these would be 2 separate outcomes. This is called ordered samples. If we generalize this to n balls and k samples, then by the multiplication rule, we will have n factorial divided by n minus k factorial possible outcomes. Unordered samples, as you might have guessed, are those samples where the order in which the elements are chosen does not matter. If we choose red ball first and then green ball, it is same as choosing green ball first and then red ball. This means the number of outcomes in this case would reduce to just 1. If we generalize this to n balls and k samples, then all we need to do is divide the number of outcomes of ordered samples by k factorial. We divide by k factorial because for every k elements we choose, there are k factorial ways to arrange them. Since order does not matter in unordered samples, these arrangements are considered same. And believe it or not, now you know what binomial coefficient is. Binomial coefficient is nothing but the number of ways to choose k elements from n elements. It is denoted by n choose k and is calculated using the formula we just derived. Let's see how we can calculate binomial coefficient using the formula n choose k with an example. In our case, n is 3 since we have 3 marbles in the jar. And let's say we want to choose 2 marbles from the jar. Substituting these values in the formula n choose k, we get 3 factorial divided by 2 factorial times 3 minus 2 factorial. Calculating this, we get 3 as the binomial coefficient. This means there are 3 ways to choose 2 marbles from 3 marbles. What are those ways? Let's see. They would be red and green, red and blue, green and blue. That's all for this video. In the next video, we will see what binomial theorem is and how it can be used to calculate probabilities using binomial coefficient. Thanks for watching.